I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by SAE standards experts, Christian Thiele and Dave Frank. On today's episode, we'll unpack how standards turn emerging technology into real-world engineering. We hope you enjoy this episode. Gentlemen, welcome to the podcast.
Well, thank you very much. I appreciate it, Grayson. Always good chatting with you and catching up with you.
Yeah, same here. Great to be here.
It's good to have you here. Christian, we'll start with you, gentlemen. Standards play a major role in society, but yet when you speak to at Thanksgiving at the dinner table and you try and explain it, what do you mean? The car just goes, the seatbelt is... No, there's a lot more, there's engineering that goes into that. How do you explain it to family and friends over the holidays of truly what a standard is?
Yeah, well, so at the end of the day, they knew what I was doing prior to me joining SAE. I've used standards all my life, right? But I was delivering bits and pieces and parts from the convertible industry to the sunroof industry. So they understood what that was. When I explained to them standards, they're like, what is standard? And I say it's a simply agreed upon way of doing something that makes things work safer, better, harmonious in the industry environment, right? And you may have never seen an SAE standard written format, but they definitely utilize them. Seat belts, they definitely understand what head impacts are. They definitely understand doors and things of that nature that are in the arena of the airline industry, but I'll let Dave touch base more on that. And standards aren't flashy, but they definitely help as it regards to a foundation of helping and benefiting humanity and ultimately industry and bringing things to scale.
You know, it's funny. I opened the car door once. I showed somebody the little metal thing on the inside of the door, and it has the SAE standard. Oh, okay. They must be important. Okay, so yeah.
Yeah. I always bring up the oil comment, right? Hey, 10WD-40, it's an SAE standard. And they go, oh, all right, we get it now. So
yeah, that's my go-to too, is oil. If I find somebody who's, especially in the family or a stranger, is just clueless, I go, we know engine oil, right? And they go, oh, that's the letters, and then, we broaden the conversation from there. Certainly, like Christian said, they are everywhere, but the engine oil is a nice, easy entry point.
Okay, great, Dave, but that's the auto side. What's the one that everybody would know for the aerospace side?
If you're in the aerospace industry, the two that always get pointed out, and there are big home run hitters, is the two safety pillars, we call them. It's ARP 4754B and ARP 4761A. So again, it's tough when we have these conversations, and I speak a good amount around the industry as well to just prevent myself from rattling off a bunch of letters and numbers with these standards. But those two are pretty fairly well known, and those are really kind of a how-to playbook on how to safely design and implement aircraft. So those are two big ones, but there's ones, and again, without rattling off a bunch of numbers, the seats, de-icing, tires, wheels, brakes, it's really a kind of anywhere you can see, if I flew with you on an airplane, it could be a long and boring conversation, but I could point to some interesting things,
Is it a fair assumption to say when you're at a barbecue or you're with friends and say, listen, the airline that you came in on, it wouldn't have happened if it wasn't for standards. You wouldn't have gotten here.
Yeah, it's, you may have gotten there, but like Christian said, what a standards for, it's ultimately, I think the backbone to safely getting there, right? And hopefully getting there more efficiently and with the newest technology available too. So that they play a lot of roles, certainly with the aviation world. Safety is a foundation to everything. We tend to move a little bit, slower in quotes, faster in the air, but slower to regulate and implement a lot sometimes, but for good reason. But the standards, I think, are play a nice secret part in the background especially to the general public, to enabling some of these things to happen.
And Christian, the technology on the ground side is changing. The air side, we're going to supersonic, eventually hypersonic flight. On the ground side, everything's becoming automated and autonomous. As the individual leading the standards effort, how do you ensure that the committees are always ahead of this new technology? Because you're seeing the tremendous impact that's occurring to the general automotive industry as these new technologies become adapted, and OEMs say, "Oh, we're going to go this way. No, we're going to go this way. No, we're going to go this way." And it's an interesting game of ping pong that's been going on now.
Yeah, and the key to understanding there is how do we come up with the ideas, and where do these ideas get created and brought to the table? It's truly a collaborative effort, and as it relates to industry, and it's not just the OEMs from the automotive arena or the tier supply base, but there is a convolence of collaboration that gets together and identifies the path forward as it relates to standards for the automotive arena and the ground mobility arena. The number one key is industry urgency, i.e., let's look at J3400. That is obviously a very important standard as it harmonizes and delivers the EV charging network that will reliably charge your electric vehicle. At the end of the day, that didn't just come out of the blue. It was something that industry convened and recognized, hey, we need to bring something that is more reliable, more robust to the marketplace for ease of use and safely usable. So that started in June of 23. And before you knew it, we had a recommended or a technical information report, then a recommended practice. And now we're going to finalize the standard on that. And we've had a couple of iterations, one, the mechanical properties, as well as the adapter properties that were developed from that. And so yeah, it truly shows how industry, once they get their head on something, they move forward quickly. And everybody then receives it on the back end, which is obviously the benefit to industry and ultimately humanity from a safety perspective.
But this is to you two gentlemen. How do you get industry, the suppliers, the interested parties, the affected parties to all come together and say, you know what? Let's check the ego at the door. We've got to do something. How do you gentlemen convene, I would say, an eclectic group of personalities to come together to do good for the benefit of society?
Yeah, it's an interesting question. Sometimes it's a push and a pull. I think, from our perspective with SAE, it's important, I think, to note that we don't typically drive, specifically. We're aware of what's needed in industry, but we often, our best job is to listen. So when we're really forcing something to happen, it's probably, not necessary, or industry's not going to support it. So it's really, maintaining a good listening ear. We're always out there looking for problems, and which ones can we solve with standards. So the more people we can get in the door, and we've got, thousands of members to pull from. Christian's always out and about, myself and our team too, just talking with industry constantly. So the more we can listen, I think the more the cream rises to the top. And, the most critical things rise to the top, hopefully before it's an issue. And really, if it's a big enough problem where a standard will solve it, there's typically enough people in industry working in different sectors and companies that are willing and able to come to the table and help.
Can you give an example in aerospace of something historically that was, we want to call it an emerging problem, and everybody came together to solve it, and then that standard went on to have a positive impact on society?
Yeah, I know in terms of a speedily solved issue, and obviously a tough incident in aviation world, but after 9/11, when they had to quickly develop and agree upon safety standards for the door to the cockpit, I know that was, and I don't know about record, but I think, at least anecdotally, that was a fairly record-breaking, speedily adopted, and I think good for everybody, standard that was put into place. So that was a pretty good example of everybody coming together fairly quickly. But, in the longer term, and I'm sure we'll get into more details, anything that's a new and advancing technology, artificial intelligence at this point is so brand new. We're forming committees on that now. That's going to be a longer drawn out process. But again, to enable it safely for the public and general application throughout aerospace, it's going to take a lot of, hard work and communication within the standards.
Christian, because there's a lot of talk and debate now, or early, a lot of engineers and saying, oh, if you're going to build a vehicle and let's say you have 10,000, 20,000 lines of code, you're going to have it written by AI. Well, do you have to verify that? What does that look like? Does that violate something? Are those conversations starting to happen yet? Because these are happening on the frontier of AI, but these conversations with engineers are starting to occur now.
Yeah, absolutely. And it is imperative that these discussions happen now, recognizing that AI is evolving and changing daily. and growing daily. And the influence, and especially in design and development, can be enormous down the road. It could be a huge cost save. At the end of the day, with the lines of code and the number of with AI and the ability from doing a data scan and data search in the seconds it takes things to happen, it may not be a bad thing for some of these software-defined vehicles and some of these vehicles to be designed with AI. At the end of the day, what is ironic and what is curious from the human-machine interface in the learning, when I was out at CES just recently, I was caught off guard by the quantity and the number of humanoids that were out there. And one of the keynotes was presented there, clearly showed the ability and the learning ability of a humanoid to mimic and do something within seconds. What took months and years to replicate for a robot, certain actions and activities through code and stuff like that. Now that thing that humanoid is observing, witnessing, and that data input is almost instantaneous. And you watch a humanoid type figure doing the same laundry activity that I would do or my wife would do, doing activities on assembly and line assembly, changing batteries. It happens instantaneously. What is it going to do for industry? It's going to be another evolution and revolution from an industry perspective.
There was a report in the Financial Times today. BMW has once again put humanoids on the line. And so it only broke 4 hours ago, so we don't have to go in depth about it. But the technology is rapidly scaling. And I think about this, Dave, a lot because you're in the sky and there's a long, let's just say 30,000 feet, is that when you start to put AI into some of this stuff, it has personalities. And you could trick it to do all sorts of things. Do we ever get to a point where there is I'll use a broad term, a personality standard where if you're going to put it in a critical element such as a plane or a car, like it has to meet some personality standard and it's verified, and I'll use a funny term, as a Fort Knox wall that it can't go past? Do you think that ever emerges?
Yeah, I think that's the big question, right? It's, it exists. It's, it's autonomy and automation, of course, is not anything new to aviation, right? There used to be, not a third pilot, but a technician or a third pilot in the cockpit that's been, automated away with a lot of features. There's even examples of certifications of automatic landing features and things like that. So, but in this newer world of machine learning and AI, like to your point, and personality wise, a big part of it is constraints. Where is it safe to implement? How can it be properly, safely verified that it's contained, and for a better word, right? And it's really placing the right limitations on what it's going to use. So I think when it starts to get into the systems, it's going to be in a way piecemeal in a very contained system or subsystems. There's again, there's multiple redundancies within aircraft. So that's the real big question, is where is it going to be allowed to first be implemented, so that I think we can learn from what you just asked. So what is the proper, again, if there's personalities involved, is there ways that the public expect us to behave? And probably more importantly, is there ways that the pilots expect it to behave? And what kind of interactions are they going to want from an artificial system like that? So yeah, I think personality is a good way to put it. I think watching pilots interact with certain systems like that in the future will be very, very interesting.
Yeah, and Dave, to your point too. My son is in the process of becoming a pilot, just at the infancy stage. But I was looking at a Cirrus aircraft, and I was online watching them demonstrate a little red button that was over the shoulder, and it's the auto land button. In case something goes wrong with said pilot, any passenger can hit that, and it will find, locate, airport, all of that, and auto land. That is automation to an extreme extent, which is fantastic, and from a safety perspective.
Yeah, and I think especially with aviation, it's a contrast of I've seen as our members and our committees work it out, right? It's, hey, we can do all these things in theory and frankly in practice. It's a battle against the traditional mindset of aviation of slow and steady is better way to go. We'd rather, in certain aspects, lag behind the latest and greatest to ensure safety. I think the general public would agree with that. But it's, like you just said, it's there. You can push a button, it'll land. even in the mass market, Airbus, Boeing worlds, autopilots take you within 100 feet of the ground or so, and then the pilots take over. So you're very close to even today, I think, being capable of doing that. But also, like you said, in an emergency situation, being able to push a button like that is
amazing.
So I think the general public, you have that kind of conversation with your aunt, your uncle, or a friend, and they go, why wouldn't that be everywhere? And there's again, there's some reasons, and it's tough to get into, but it's the whole question of automation and what's allowed, and again, regulators obviously have a say as well. So
yeah, and on top of it, they have another lever for a parachute. So I mean, they've got redundancy systems.
The parachutes.
Yeah. But that is so true, and we recognize it in the automotive space. I was at an ESC event. Oh my God, this was in Japan about 3 years ago. There's another EVC event coming up here in Toronto. And 3 years ago, they were showing testing as it relates to automated driving, ADAS features, and things of that nature in the automotive arena. And these were third parties, universities, and testing labs, governmental testing labs that were doing these tests. And it was surprising and astonishing 3 years ago what it looked like as it related from an automated space. And today, what I'm hoping to see is recognize the vast improvement that has happened. Because I stepped into a Waymo 4 years ago, and I was bare knuckled and gripping on to everything for dear life. And today, when I was out at the ATS event with SAE out in Phoenix a few months ago, I drove in a Waymo, and I was like really calm and at ease. It was ironic how human-like this machine was operating and functioning. And so we've come a long way. But there's still a lot of path forward. I mean, we are dealing with J3016, still revising it and making it a little more palatable for the general consumer. The engineers and the technical folk get it, but just so people get more comfortable with it. I think that's one of the biggest challenges that we have, even from a standard organization, from an industry organization, is to let them know that, hey, the automated driving systems, and especially the ADAS from a safety perspective, there is a level of reliability that really, really benefits that humans can't, as much as I love to drive, that humans down the road will be a hindrance to at the end of the day, right?
It comes down to trust at the end of the day. Do you feel that standards build trust?
Yeah, I think definitely within the industry, right? And we'll say from the aviation's perspective, trust with regulators is huge, right? So everything we build in aviation, not everything, but the largest thing, if you're going to carry passengers, it's going to fall under the FAA here in the US and other, CAA authorities around the world. So they need to trust that you've built it the right way, you've built it safely. A lot of the regulations that in, years and decades ago were more written to be very prescriptive is moving a lot more and has moved towards performance-based, right? So we want it to be this level of safe. Well, how do you do it? A lot of times they'll point towards standards. So again, even though to the general public, like how we started off this conversation, you may not know anything about the standards, but they're there, and more so, especially with newer technologies, it is building the foundation and that body of proof that builds the trust with regulators and then around the industry, because then everyone's a lot more aware that, even if you're doing your own yourself, I think it's the safest way. I think it's efficient. I think I checked all my numbers and I think it's the best way. But, you get in one of our committees and you go through the work of a standard to prove it out with everybody else and your peers. And, by the end of the day, then I think you're a lot more trusting even in your own work.
Yeah. And Grayson, from our side, as it relates to even from a marketing perspective, understand, first of all, the committee members, right? You've got your OEMs, suppliers. You've got now, especially a lot of startups are more engaged, right? It's not the traditional folk anymore. You have academia, government agencies, third-party labs, as mentioned earlier. But the key is now, because of the diverse portfolio of people engaged in developing these standards, at the end of the day, when it's published, what we do too from a marketing and a deployment perspective is really not only cater to, obviously we have our stakeholders that want this information and need to understand from a technical level, but we start to really engage now the public and let them know, again, it's building that trust, let them know what it's about as it relates to the standard. And once you build that trust, they recognize the viability, because at the end of the day, it's all about the safety aspect. It's all about deployment and harmonizing to make sure that the end consumer gets the benefit. And what it does for the industry, obviously it builds scale. It allows them to have a return on investment on their engineering by allowing their people to engage in the standard development process. And from a regulatory and a government and an academia perspective, there's research, there's testing, so it's a full circle scenario. And then at the end of the day, the government regulatory side allows them to be able to reference, because, hey, standards, let's be clear, 99.9% of the time are even better at a higher scale than any regulatory framework that's out there, because industry holds themselves to a very, very stringent safety standard.
Do you view standard as the good housekeeping seal of approval?
Yes, absolutely. And that's why this landscape has become so competitive. And it's not even just it's not even just in the automotive or aero world, right? Standards are in everything that we do. Electrification, UL, I mean, the laptops, the computers, the plugs, the adapters that you use, it's all part of it, right? So there are other organizations that specialize in things, and hey, we reference those things too, because we can't be everything to everybody, but we utilize and allow ourselves to utilize our partner SDOs that are out there to help develop some of our mobility system standards.
Dave, when you're bringing individuals together, I'm sure you have some retired individuals from FAA, Lockheed, Northrop, your Boeing, your et cetera. How does the process work for coming together? Can anybody get involved? And then when the curiosity hat goes on, how does the voting work as everybody tries to, okay, we're going to do it. We're going to do it. We're going to agree on something.
Yeah, good question. Recruitment is huge for us at SAE. The way we're structured, it's free for members to join. If you've got a passion for it, if you're an engineer, you're a problem solver, an expert in your field, there's a good chance you're in aviation mobility. We've got a committee working on something that you're working on too, and it's already full of people that at other companies that do it with you. Regulators, of course, with us, FAA around the world, the other CAAs, Transport Canada, ANAC down in Brazil, EASA, the Europeans as well. The more the better. And to your comment on the stamp of approval, right? That's the big word we use is consensus. So if we go at a standards committee and it's just Boeing showing up to tell everybody else, what the safest thing is, well, that's not a true consensus. All these organizations have internal, in quote, standards as well, right? They've got their own best practices, but it's not a standard. And that's the true difference is that everybody gets a say. And that can be the hard part, right? So everybody does get a say. And that's when the voting comes in. We'll say, I think the way we're structured in a general committee with 100, 200 people, there's a smaller contingent of voting members. And these are the really truly committed members that have contributed. They've helped out with the document. They've put in the time. They're consistently there, right? They're the VIPs, the MVPs of the committee. So they get a vote, right? So we need to reach consensus. Although everybody in the committee does get a chance to voice their concerns. And that's our commenting period when it goes to ballot, right? So document gets, rough draft, basically ready to go, goes to the committee, everybody gets a chance to comment. And we differentiate the comments, right? They can be just, typo comments, things like that, not a big deal. But when it comes down to the technical comments, that's where, the true consensus process and the wheel starts to turn. So it can be contentious. It can be as easy as, some things are simpler than others, and it's not that big of a deal. And we'll have documents and comments go through rounds and rounds, and it really gets worked out. So, in that sense, it's tough to sit and watch because you really, you want to get out the door, you want to get published and let the public use it. But in other sense, it's also makes you understand, why these are valuable, right? This is not just, they don't get rubber stamped and pushed out the door. I've watched some of these go on for a long time, and it's some serious debate. So.
Yeah, it allows, at the end of the day, the consensus that we draw, it truly delivers a quality product. We have in the automotive sector over 12,000 now. It was about 10,000. We've grown that by about 20% in the last 3 years because of the new emerging space and everything. People get excited, but I tell you what, sometimes the challenge is there. The J3400, we had 120 engineers in the room, and I'm an engineer. I've worked with engineers all my life. You put 120 engineers in the room, God bless you. Trying to get something accomplished at times becomes somewhat challenging. But at the end of the day, it's truly robust. So the end product, be it a TIR, be it a recommended practice, be it a standard, a full-blown standard, you recognize that has been a truly vetted product that industry can buy off on and take hold and move forward to allow, obviously, from a regulatory compliance foundation, clear expectations for product performance, interoperability. All of that is delivered and lowers trade barriers and purchasing costs. And all of that is delivered to the industry, which ultimately benefits us, the end consumer, because of the safety and the reliability that has been bestowed through the standard.
Dave, when you're a committee, where does experience come in? Because I've read stories from around the world. There are certain pilots that won't fly certain airlines, that won't land certain airports because of altitude or wind conditions. And there's a lot of variables from their real world experience of flying around the world with weather. So you have one individual, let's just say a very seasoned individual, and then you have a newer individual that's fresh out of school that has theory. But how do you get these two individuals to come together, taking 30 years of experience, 4 years of theory to come together?
Yeah, it's not just, there's certainly varying degrees of experience, expertise, personal preferences even, right? The classic debate is always in aviation is Boeing, if it's not Boeing, I'm not going, right? That's on all their stickers and merch. That's been a long-standing saying on the Boeing side of things, which, rhymes and sounds great, compared to the Airbus. So those people are all there, right? And we've got, Europeans versus Americans and things like that. And it's not always, versus situation. But experience-wise, I think, again, it's to fall back on the consensus process. If we've done our jobs, Christian, myself, and everybody at SAE, then that room is full of people that, have 100 different opinions and things like that, strong-minded or not. So I think best practice is if it's somebody who's less experienced, we want you to speak up and voice that concern. It's something that maybe a, grizzled veteran maybe doesn't want to hear, or has been ground down by the world or whatever else and has slightly different opinions. So maybe a nice fresh burst of optimism, or again, a newer idea perhaps too, right? So something that out in the industry they haven't been exposed to as much from some of these newer concepts and ideas. And of course, in between, you're going to have people that are right in the middle. So, not that they need to mediate, but I think once you get a mix of all these people together and just allow the conversation to go, and as long as everybody is a willing participant and is fairly friendly and able to exchange, their opinions, then usually there's a way forward.
You have an idea, Christian. Okay, so there's an individual engineer, let's say a large OEM has an idea, thinks to become a standard. Does that individual call you up? Does it call a colleague of yours up? How do you get if you want to call it the consensus to, if you want to say, start the baby step before you even get to the first step, or the hover before you go? How does that whole process work?
Yeah, there's SAE ITC, which we have also consortia. It's one of our partner sister companies, where industry sits together and talks about issues, concerns, and what the emerging space looks like and where the next opportunity lies. That is one way. But at the end of the day, where you hear it, where you see it, events like CES, it's at the auto show, it's talking and visiting these C-suite folks and seeing, hey, what are you guys working on? What's foundationally happening moving forward into the future? Those are keys. So it's continuously for us at our level and with our technical experts, subject matter experts, continuously engaging with industry to recognize and understand what's coming up next. And you see that AI, obviously 2-3 years ago, really took storm. And how is that going to be impactful? How is that going to shape the industry moving forward? And what is going to be involved? Software-defined vehicles, right? What is that platform look like? Everybody's doing a little bit differently. How can we, and right now the government and everybody's talking about cost. How can we help from a standardization point of view to reduce and drive those cost problems down so people can afford some of these new advances in safety and technology more rapidly, more quickly through economies of scale? That is what we bring. And that is what these guys try to focus on and deliver. We have, I think, 30 plus events throughout the year that SAE hosts, where we bring these discussions together, panel discussions, to really, and this is where some of these ideas start getting flagged, and we recognize where those opportunities are.
Dave, you can't go a day without hearing SDV, software-defined vehicle. How about from a plane? Is there a SDP? Is there a software-defined plane that's in the works? Where are we? Because you don't really hear much about it.
Yeah, and to be honest, the term really strikes me as a little bit foreign myself. So it's I think that maybe speaks to it pretty bluntly there. I don't think that's a a concept that's really, I think, pervasive in aviation. Again, software is everywhere throughout the aircraft. I think more in line towards the automation features where that language sits, right? It's just the terminology that I see most often is just increased level of autonomy, increasing autonomy to the point of, and we see it the most often in the AAM realm, right? So advanced air mobility, that's the latest and greatest in aviation. That's the newest wave that's coming. If you're not familiar, of course, this is the, in quotes, air taxis, eVTOLs, electric vertical takeoff and landing aircraft. We've got 2 in certification with the FAA that are trying to get certified this year. So that's really the realm where we're pushing. Again, we're not using that acronym specifically, but those aircraft, we're certainly years away. But as they move towards single pilot operations down to fully autonomous, that's certainly going to be a software-driven vehicle. So that's where it's headed, but it's far off enough now that it's not quite in the lexicon yet.
Is the drone delivery industry starting to get standardized? I asked that recently because recently, globally, 3 million packages have been delivered autonomously with a drone. We passed that milestone this week. Has standards started to emerge into the package delivery drone? That's not your consumer drones or your amateur photographer drones, but your goods deliveries. As you see in Kenya where they're delivering medical products, or you're seeing in Texas where they're delivering Walmart. Has any of that started to get standardized yet?
Yes. So the drones themselves, your UAS term we use is getting standardized for sure. And it's a mix. So we have on one end, I'll say we've got AAM and the larger 4 to 5, 6 passenger carrying larger vehicles. And then we've got, small quadcopters, UAS. As the technology has ramped up so fast and the delivery concept is there, the next general advancement you're going to see is, I think, into the cargo operations. And to do that, these drones are going to move closer and closer to that size of a Joby and Archer. Those are the big names. Again, those are the ones I mentioned going for certification. So as those size up, and in between as well, you're going to have personal, I think the term we like to use is personal electronic aircraft as well. You're talking single pilot operations. It's going to fall into more of a GA category. And there's something where they're making sales now. There's a couple out there now that you can buy as an individual and you can fly in the same way that you would fly your Piper Cub. You can take off in these eVTOLs yourself now. So the point I'm trying to drive towards, I think, in standardization, a lot of these smaller aircraft that operate in a less regulated world in the FAA sense of the thing are moving closer and closer to the more regulated world of the higher transport category aircraft. Where standards can come into play is, I think, in that traditional sense, where the heavier, larger aircraft have been more regulated and standardized. I think these smaller aircraft will benefit more and more from utilizing and looking up, for a better word, into where a lot of work has already been done to, in some sense, it's over-engineered to utilize some of these standards, perhaps, and it depends on the purpose. But I think it'll lend a lot of more credibility and safety to that category. So all the way down to drones, these standards can apply, and there's a lot of work going on.
Christian, there's a lot of similarities, both the ground side and the air side, going full speed ahead, embracing the future. As both sides are embracing the future, what are some really exciting standards that you're working on that's going to have a positive impact on these emerging technologies?
Well, one that's exciting is J2954 from our side, which is kind of fun. Matter of fact, I'm going to be out in Utah with a CRP. A CRP is a project, a funded project that we do with various organizations. This is industry provided. This is not government provided. So these research projects are important and vitally critical. But the J2954 is focused on not only static, but dynamic wireless charging. Think of a slot car, which is wicked cool, right? So what would that do? Well, look at all of the issues and concerns that we have from an environmental perspective as it relates to the size of batteries, putting batteries in the Humvee, right? It's the size of a tank, and you've got the battery the size of a large battery, right? But what would this do? This so-called dynamic driving and shuttling on a roadway, like a slot car, so to speak, it would reduce the size. It would reduce that impact of what we would have to do with these natural resources that we have to grab to pull forward. So that's really cool. Wireless charging makes it easy too from a disability perspective. Have somebody pull up, charge your vehicle, and back out on a static area, right? Which is vitally critical too. So that is one of the cooler ones that I'm actually excited to see where that goes. I know there's a chunk of road on 94 that here in the great state of Michigan that has that deployment capability and testing capability. And I know it's going to shape the future. Is it here in 2 years from now? No, but definitely down the road it will be, and you see it already being utilized to a certain degree in factory settings, plant settings at smaller scales, and where it would be really beneficial would be probably in logistic areas, shipyards, and things of that nature, where they can continuously move without having that massive invest as it relates to the vehicles themselves from a battery perspective.
On the logistics side, no downtime, lighter weight, so you can do more from an operational efficiency standpoint. From the consumer standpoint, the whole debate around range anxiety goes the way of the dodo bird. Bye bye.
Gone, instantly gone, which is fantastic, right? So,
Dave, what are you excited about for standards in aerospace? As we said, it's changing. I haven't been for an eVTOL ride yet, but it's coming. So, what are you excited for standards there?
Yeah, I'll go back to the AM realm. So one of our keystone groups is electrified propulsion, right? So that's really the keystone technology. I think that's going to move the industry forward, and we say it's distributed electric propulsion. So where these aircraft are really benefiting, and it opens up the whole design portfolio, is these electrified propulsion systems where multiple engines, multiple motors, hydraulic systems gone. The pain of all those systems and the complications there, and drive shafts and things like that from traditional engines just completely removed. So that company's been fantastic for us, delivering a lot of groundbreaking work. They're working on right now. They started out, again, simplifying and defining the industry and the terms they use. They're working on durability tests for aircraft engines now. What about electric propulsion aircraft ingestion, right? So these are new aircraft flying in new ways, in smaller rotors, in urban settings, perhaps. You're down in the bird zone and things like that. Everybody's pretty aware of the bird strike danger. So what happens when you've got 50, 40 eVTOLs flying around the city? So good questions to ask. And we have traditional committees as well that look at strikes, on aircraft services, but the propulsion group's there. We just stood up a new committee on digital engineering. So they're not producing anything yet, but that'll be, that's a rising field within aviation in the world there. G34, our artificial intelligence group, they're looking to put out assessment on human factors for AI, as well as process standard for development towards cert and approval. Again, so what we talked about here now, how do we certify these things, right? It's always the ultimate question. I want to do all this cool stuff, but it's got to get certified. So a lot of these new technology groups, that's keystone of these standards is what can we do with these things? How do we get them certified? So those are some great things. We haven't touched on it yet, but with AAM and the electric propulsion, with batteries, there's the big limitation with aircraft is they're heavy. And that's not going to change anytime soon. So from what I understand, generally, the battery tech is fairly topped out from right now in terms of weight reduction and power per weight. So the obvious next step there is, move to a different fuel source, right? So utilize all these great advances in electric propulsion, switch to what's next, hydrogen. We've got a number of groups working on the hydrogen question, and that's liquid, that's gaseous, that's infrastructure. So really cool work going on there, as well as some SAF as well. So the sustainable aviation fuels. But those are some really cool work going on. It's great to be a part of. It's everything's centered around that AEM realm and the electric engines and hydrogen. It's going to be some real cool stuff.
As electrification gets more introduced into aviation and you start to experiment with AAM and different fuels, does that start at regional airports? Since they're smaller airports, you can go shorter distances. Is that a sign for us to look for? Okay, this technology is starting to emerge, starting to take off. There's been an increase in these regional airports. Is that something that we should watch for?
Yes. So I think there's two real use cases where you'll start to see these vehicles first. I think first and foremost, they're going to fly the traditional helicopter routes at the traditional cities you would expect, right? So they're going to be an air taxi service. Their range is limited because of the batteries and the current technology to about 25 to 50 mile routes, right? So that's New York City, that's LA, that's Miami. They can fly over water. That's, not over, humanity and buildings. Fantastic. So you'll see that. And, but where I think the larger market is going to be this regional air mobility. It's another term that gets thrown around, but there's hundreds, if not thousands, of underutilized, if not utilized at all, small airports everywhere in this country and around the world as well. But the United States specifically has them everywhere. And Perhaps the straight eVTOLs with battery powered may not have the range to fully utilize that capability, but with an affordable system, maybe a turbogen or a hydrogen system that has that, we'll say a 300 to 500 mile range, that's where you can convince people that's where you can really, I think, change the world and change aviation. Years ago now, years ago, maybe 10, 15 years, there was a push for these micro business jets essentially. And that was a similar concept. But I think cost and technology kind of swamped that in terms of a real life marketability. Whereas these electric propulsion combined with the right fuel source, I think have really opened the door to an affordable way to move people around.
That sums it up, because what you described, hybrids, is what we're seeing, Christian, as you well know, sir, in automotive. The rebirth or the regrowth of hybrids, and hybrid technology is having a positive impact, not just in automotive and aerospace, but across the board for all sorts of different energy aspects. Gentlemen, this has been a fascinating conversation around standards. As we look to wrap up, what would you like to take, as we look to wrap up today, what would you like our audience to take away with them today? Christian, we'll start with you, sir, please.
Yeah, mobility as we know it, especially in the ground vehicle space, as well as in aero, is changing quickly. Electrification and the different means of electrification, but also the different powertrain platforms that are out there, from hydrogen and other opportunities that we have. Autonomy. Automated driving is coming, and the challenges. I'm looking forward to the next ESV that's happening in Toronto to see how far we've really come in the last 3 years as it relates to safety, as it relates to automated driving. And our role at SAE is to make sure this transformation happens safely and collaboratively, and we deliver the quality product at the end of the day that standards are known for, and especially SAE standards. So I'm looking forward to that.
Standards make the world go round. Dave, what would you like our audience to take away with them today?
Yeah, I think if you're part of the general public and you've never heard about standards before, I think hopefully we kind of opened your eyes to they are everywhere. We are a backbone of safety in the community and mobility. And I think if you're in that world, you're an engineer, you're an expert. I'd say, as always, please come by and check us out. Please help out. It's free to join. It's free to participate. I try to tell people all the time, you get to grow, as you talked about before. You're a brand new engineer out of school. Come and learn from the best people doing it around the world in your industry. You don't have to contribute immediately. You can just sit and soak it up and then slowly work your way in and then use what you're starting to do in your day-to-day to help us out and help the rest of the industry. And if you are a more seasoned, expert, more the better. So I guess, general call is just, please contact us and please get involved.
Yeah, especially recognizing and understanding the emerging space that has come along, and recognizing all of the new upstarts that are out there. We have a lot of young, bright minds. It's not about us older folk. It's about bringing the young, bright minds to the table, and the networking opportunities and the growth opportunities within these committees and task forces at building these standards is endless. And we look forward to having you guys participate and join us. SAE.org is one way, and joining the organization through that.
Get involved, roll up your sleeves, and develop standards, because they will have a positive impact on society. Today is tomorrow. Tomorrow's today. The future is standards. Christian, Dave, thank you so much for coming on SAE Tomorrow Today.
Thank you so much, Grayson. Always a pleasure. Dave, a pleasure.
Yeah, thanks, guys. Appreciate it.
Take care.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
Be sure to join us next week as we explore 2 important AVSC efforts that are shaping the conversation around automated driving system safety.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.